Everyone, can't be there with you. Got to take care of family today. Life happens. Um, if you are in my period one class, it's going to be a extra long period for you. So there's going to be a back-to-back lesson. If you're in my afternoon class, it's just going to be this, and you can expect a double lesson of 6.2 and 6.3 tomorrow. Now, please note, I know that I sort of bend the rules a little bit with people going to the washroom maybe two people at a time. But this teacher, whether it's a substitute or another teacher native to Northern, that is on call, they may not know you, you may not know them, and so be respectful. I am going to enforce and ask everyone to be super respectful of the one person to the washroom at a time rule. Okay, it's going to be the school expectations. Please be mindful of it. Please adhere to it, and I hope I don't hear anything bad about people. Okay, I trust you. Now, lesson today. Please note it may be a little bit fast because a lot of it is a review from grade 11. Okay, if a lot of this is not familiar to you, I ask that you take some time to go over it again. Okay, and I'll see if I could direct you to some extra practice questions at some point. All right. Now, exponential functions, something that you know. Something that you know. You know that, oh gosh, I don't want that. I would like a normal line. Okay. You know that exponential functions from last year starts with an asymptote, but at a certain point, it hits a y-intercept of 1 and it shoots up. That would be your basic base to the power of x exponential parent function. Okay, it always has a y-intercept of 1. I want to talk about this in general, talking about what that might look like, what this is, what that is, and then refer to this keyword called inverse. Inverse is not opposite. Inverse is not reverse. Inverse is its own term in the math language. Okay, and depending on how you learned math, this might be something that is completely new to you, but you might have learned it using a different word, or whoever taught you might have just been really flippant about it. Inverse, in essence, is this: when you have an addition in an equation and you want to get rid of adding something, what do? You do the inverse, and that is subtraction. It's not reverse, it's not opposite. I know it's very tempting to call it opposite, but it's called an inverse when we're talking about an equation because you're getting rid of it. You are undoing the process. Okay? If you have a multiplication, how do you get rid of a multiplication, or how do you undo a multiplication? You have to divide it. Same thing with an exponent. If I have a x power of 2, how do you undo a power of 2? You square root it. It's that idea. It's not a reverse. And the best analogy I have is if you have a sock and you throw it in the laundry machine or something, and it becomes crumpled and it becomes inverted inside out. Okay? You're not flipping it to become opposite. You are not, reversing a side or anything like that. You have to literally flip it back outside in to undo what happened. You get what I'm saying? And so please try to make a distinction between doing something that is opposite versus doing an inverse. It's small, it's subtle, and it might seem really annoying of me to demand it, but it is absolutely important that you understand what an inverse actually is in a function context. Now, sometimes you might have a fraction, a base that is between 0 and 1. What does that look like? Well, in fact, 1 over 2 is actually a reciprocal of 2. So you can say it's actually 2 to the power of negative 1. 2 to the power of negative 1, using exponent law, is 2 to the power of negative 1 times x. And what do you know about a negative value multiplying to the x variable in a function? It's a horizontal reflection. And that is why 1 over 2, when you graph it, is decreasing by half every single step of the way, which looks like a horizontal reflection. Okay, so this is not reciprocal. Sorry, this is reciprocal. Inverse is something else. Okay, now why are we talking about inverse? Sometimes you need to know. Inverse, if you didn't know, is essentially making the x and y positions flipped. Let me give an example. Okay, you may. I'm going to say something slightly controversial. I don't know how people it is, and I hope I don't get flagged on YouTube on it or whatever, because I'm not even that popular, anyways. But a long time ago, Al Gore released something called an inconvenient truth. Al Gore was I guess, vice president long time ago. Anyway, there was a correlation he made saying, hey, the more carbon dioxide there is in the, in the atmosphere, the higher the global temperature went. And it was like, what? Are you serious? That's right. The more carbon dioxide there is, oh my goodness, it's starting to go up. We see a trend. Everyone, we got to stop this. Okay, we got to stop the coal burning. We got to stop the cars. We got to stop the cows. We got to stop everything because temperature's going up and we're going to die. Okay, and everyone's freaking out. But as scientists investigated more and more, they realized there was a little bit of a lack of scientific integrity. In fact, what they found was the independent variable and dependent variable seemed to have been, there was some shenanigans. Sometimes, what I'm trying to say is this. Sometimes there is a need to see if the x value and the y value need to be switched from independent to dependent and vice versa. And what they found was the temperature of the earth continues to fluctuate. And when the temperature got hotter, more water evaporated, and the carbon dioxide dissolved in the water, sort of like sparkling water, right? Like Perrier or whatever. All the carbon dioxide that was dissolved in the water, because the water evaporated, more carbon dioxide released into the atmosphere. So now there was this controversial conspiracy of, did Al Gore do this to just earn a lot of money as a big spokesperson? And he was like he was an influencer before influencers were cool, right? Did he do this by being paid off? There's so much controversy, and even now people are like, what's real science? The internet doesn't help us with that because internet is full of truth and lies together, right? What I'm trying to say is there might be a need to flip the x and the y. There might be a need to do an inverse. Okay, so here's an example. Let's take 3 to the power of x. And we're going to draw a table from x equals -3 all the way to +3, and we're going to graph it. From there, let's see what it means to undo something and draw the inverse function. Here we go. With the space on the left side, take about half of it, and let's draw a table. Okay, nice and big. This is my x, and my y, which is f of x, is 3 to the power of x. My x table has -3, -2, -1, 0, 1, 2, and 3. 3 to the power of 1, 3. 3 to the power of 2, 9. 3 to the power of 3, 27. And I hope you see the pattern. I am multiplying by 3 all the way, which makes sense. That's what the base is. So if that's the case, what if I reverse it? 3 is divided. 3 is divided, and so 3 to the power of 0, that's a 1. 3 to the power of -1, you continue to divide. 3 to the power of -2, you continue to divide. 3 to the power of -3, you continue to divide. And that's it. Let's go on graphing it. In this graph, my y value jumps to 27, so I might need all the space in the world here. Let's see. I'm too lazy for this, so I do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a 10. 1, 2, 3, 4, 5. That's 15. 1, 2, 3, 4, 5. That's 20. 1, 2, 3, 4, 5. That's 25, and that's 30. You might be wondering, why are you going so high when the x value only goes to 3? You'll see later. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. There we go. All right, let's do this. When x equals 0, I have a 1. X equals 1, I have a 3. X equals 2, I have a 9. X equals 3, oh gosh, I have a 27. That jumped huge. Left side of the y-axis. Negative 1, 1 over 3. And 1, closer and closer to the x-axis without ever touching it. Ooh. There. Draw as best as you can. We're not marking here on accuracy. Okay, so this is my exponential function. It's not the prettiest, but I hope you'll understand. Now, here's where it gets interesting. I am going to undo. Okay, I am going to switch the values for the x and y. Okay, I don't know what that is represented by. I don't know what that's going to look like yet, but I am going to switch the values for my x and y, because that's what we just talked about with the carbon dioxide example. So my y of x value is 27, 9, 3, 1, 1 over 3, 1 over 9, 1 over 27. So I'll give you a moment to write this down while I talk a little bit about it. So this inverse, why did I talk about inverse here? Why do I talk about undoing something? Take a look at these two charts. And pay close attention to how I say, or how I use these numbers, okay? For the original function 3 to the power of x, I put in a negative 3. I get out 1 over 27. I put in a negative 2. I get out a 1 over 9. And when I put in this, I get out this. I put in this, I get out this. I put in this, I get out this. When you do the inverse, what you're really doing is saying, if I get out this, what did I put in? If I get out this, what did I put in? If I get out this, what did I put in? It's technically, you can think of inverse like that. At least in the direction I want to go for next lesson, I like you to think about it like that. Okay? And so when you do the inverse, you are changing the independent and the dependent. And so, or you're just inversing the direction. And so it's sort of like before, here's the question, what's the answer? Here's the question, what's the answer? When you do the inverse, it's like, here's the answer, what was the question? Here's the answer, what was the question? I'd like you to think about it in that way as I try to draw this. So when x is a fraction, positive 1 over 27, I get negative 3. And 1 over 9, I get negative 2. 1 over 3, I get negative 1. And then I get 1, 0. If the answer is a 3, what did I get? What I put in a 1. If I get a 9, I put in a 2. If I got a 27, I put in a 3. So when I dot this, you should notice something interesting about this shape of how I flip, or how I changed the location of x and y. When you do the inverse, it looks like you have reflected on a y equals x line. Isn't that cool? It always happens. When you change the location of x and y, you in turn look like you are reflecting on a y equals x linear equation. Okay, so let me write that down. Pen. This is y equals x, and this pink line, y equals, right now we don't know what it is, so I'm going to give it a symbol. Y is the inverse of f of x. This is not an exponent, It is a symbol for the inverse. Just like sine to the power of -1 or cos to the power of -1. Remember that? We say power to -1, but it's actually inverse sine of a ratio. Inverse sine of a ratio. Right? And you get the answer. Does that sort of make sense? Even for sine, it said, if my ratio is 1/2, what was my angle? If the answer was 1/2, what was the question? It should sort of ring a bell. It's just sort of, you should be able to tie or connect the dots a little bit. We're doing the exact same thing, but with an exponent. Okay? So this is what it looks like graphically. We are going to try practicing graphically again, just to show this is always true. But we're also going to expose ourselves to some algebra. Ready? So inverse functions, f of -1, so it's actually not an exponent, can be derived from the original function f of x. How do we do that? We literally swap the location of x and y, and then we're going to isolate for y. Okay? And when you have that new function, you should be able to graph it, and it should look like it's reflecting on the y equals x line. This is actually another review from grade 11. So if you don't remember, I'm going to ask you to remember. Here we go. Y, so f of x, -2, multiplied, we have a parabola, x plus 1 squared, plus 4. If you're in the business of calculating the inverse relation, I'm going to ask you to swap the location of x and y. Okay? And the rest is just algebra. I need you to isolate for y, just like how y was isolated in the original. Okay? Here we go. So doing algebra here, I'm going to subtract both sides by 4. Next, I'm going to divide both sides by -2. But for the sake of transformations, instead of dividing both sides by -2, I'm going to multiply both sides by 1/2. I'm going to do that instead. So multiplying by -1/2 is the same as dividing by -2. From here, I need to square root both sides to get rid of the square. And remember, if I square root, I need to, because I am introducing the square root, it holds the potential to be both plus and minus. And lastly, subtract both sides by 1. So y equals, and leave some space, this is equal to plus or minus -1/2 x minus 4 minus 1 on the outside. And this is my f of, so inverse function. I should really stop saying f of -1. This is not an exponent. So if I say that, correct me. This is inverse function. Okay? Inverse f. Let me say it like that. All right, here we go. So graph it. So we are going to take my parabola, let's graph it using transformations, and then I will quickly graph this using transformations for you. That's not part of the lesson, so I'm just going to do it very quickly. If you're not sure how I got it, you can ask me, or you can review your transformations with, a square root function. All right? And with the minus portion as well. And from there, the $1 million question for today. Here we go. Transformations. X plus 1 plus 4. My vertex is negative 1, 4. Okay, that's negative 1, 4. And then I'm going to draw my parabola with a vertical stretch and reflection of 2. So that's 1, 2. So 1, negative 2, 1, negative 2. And then 2 to the side, 8 down. And then 2 to the side, 8 down. This is my parabola. That's not very pretty, is it? Let's see if I can do better. Not bad. Okay. Now using my pink, let's see. My square root function starts from 0, 0. There is a reflection. There is a stretch of 2. Move to the right by 4, down 1. So 0, 0, move to the right by 4, down 1. This is my start. And now there's a 1, 1 and a 1, negative 1. Reflection, stretched, 4 and 1 down. Let's see. Reflection, stretched, 4 and 1 down, and 1 here. And then 4, 2. Reflection, stretched, 4 and negative 1. 4, 2 is reflection, stretched, 4 and negative 1. And down here. So again, I did that really fast. If you were able to keep up, amazing. If not, it's just transformations. So it's very, very doable to review. Now take a look. I know I'm doing it right because look at that line. The y equals x line. There is a perfect reflection. And it looks like there's like a, right? There is a intersection right there, which makes sense. So this would be inverse function, right? And this would be my just f of x. So again, all of a review of grade 11, how to swap x and y. But here's a $1 million question. Ready? If this is true, if you can do the inverse by swapping x and y, then we should be able to do the inverse and get this pink one by swapping x and y, as we did here. It makes sense. But it gets really hard when you do it algebraically. Consider, f of x is 3 to the power of x. Ready? Let's swap. X equals 3 to the power of y. How in the world are you going to get y all alone? How do you take an exponent and drop it as a regular constant or a regular variable? Right? How do you do it? Right now, we do not have the tools. You don't. All I know is, because it works for all the other functions when you swap x and y, I know we can. But I don't know what to call this. The only thing we have is that it's an inverse of the original function. But that's not enough for a mathematician. We need to give it an identity. Otherwise, this is going to drive us crazy. Because clearly, it's a function. There is no overlapping y values for every x value. Right? It is a function. We need to give it some kind of identity. And that is the beginning of 6.2. So what I'm going to ask everyone to do, if it's my period 1 class, you're going to get a break until 10 o'clock, I think. Okay, until we, you're going to catch a break. There are some textbooks available. If you want to try and get used to and do a big review of exponents and doing the inverse of any typical function, dig into page 319, number 5 to 10. But otherwise, take a break and stay tuned, because we are going to look into giving this function or the inverse of this function an actual identity and a method of writing it so that the entire world sort of understands. Okay, it's a new system. Get hyped, get a break, and yeah, suffer well. I will see you soon. Bye.